Hello everyone, welcome to another video on driven maths and physics. Thank you for tuning in. In the previous lesson, we managed to look at one example on how we could employ the formulas that we've come up with so far in uniform circular motion. And in this video, we're going to expand on that. We're going to do 2 or 3 examples just to make sure that we cement the ideas that we developed in the previous lesson. And so let's dive into it right now. Now, the problem that we're having here is a problem on angular velocity. The problem says calculate the angular velocity of the Earth when it is rotating about its own axis. And they're saying the time period of the Earth about its own axis is equal to 24 hours. Okay, so first of all, we need to remind ourselves of the formulas that we came up with for angular. Okay, angular velocity. Okay, this concept right here. Okay, so the first formula that we came up with was angular velocity is equal to angular displacement over time. Remember, theta is angular displacement, t is time. Okay, and then we had omega, which is angular velocity, was equal to 2 pi over capital T. This capital T was periodic time. Okay, then we had another formula that said 2 pi f. The f was frequency. Alright, and so we had these 3 formulas that we could employ in solving problems to do with angular velocity. Now, what we're having here is it's a problem where we're given the time period of the Earth about its own axis. It says it takes 24 hours for the Earth to rotate about its own axis. Okay, so we know that our t is equal to 24 hours. Okay, but remember that the units for angular velocity are radians per second. In the units there is a per second. A per second is what will tell us what we're supposed to do with the periodic time given. The periodic time is given in hours, so we need to convert that to seconds for us to use it in the formula so we can find the angular velocity. So how do we convert this to seconds? We know that 1 hour is equal to 3,600 seconds. Therefore, 24 hours will be equal to 24 hours. Okay, divide by 1 hour multiplied by 3,600 seconds. When you multiply those two things, what you end up getting is 86,400 seconds. This is equivalent to 24 hours. So time period is 86,400 seconds. Alright, so now we have a formula that we can use to calculate angular velocity. It's equal to 2 pi over t. This, after substituting, it will be 2 pi over 86,400 seconds. Okay, this now will become 2 times pi divided by 86,400. Okay, now what we end up getting is 7.272 times 10 to the power negative 5 rads per second. This should be our solution. Okay, this should be our solution. Okay, I hope that makes sense to you, but it's very, very simple. All you have to remember are the units of the quantities that you're calculating at the same time. Remember the formulas and the relationships within these things. Now let's look at the next example and let's see if this will be much more simpler. All right, the other one is this one. Now the second example says a bow tied to a string is rotated at uniform speed in a circle of radius 10 centimeters. Okay, so it's rotated at uniform speed. We know rotated, and there's uniform speed. We know we're talking about uniform circular motion. Okay, and in a circle of radius 10 centimeters. Okay, and it takes 1.5 seconds to describe an arc of length 6 centimeters. Calculate its tangential velocity. Okay, tangential velocity. Now, remember, when we're talking about angular, a circular motion, we can have something like that. And then they're telling us here that we're moving from point A, then we're arriving at point B, which happens to be 6 centimeters. And we cover this arc length in 1.5 seconds. Okay. And we know the radius is just 10 centimeters. They are saying calculate the tangential velocity. So what do we know about the tangential velocity? Remember, we looked at this formula that said velocity or tangential velocity or linear velocity was displacement over time. You remember in circular motion, this displacement is simply the arc length. Okay, this is not angular displacement, it's just a displacement. The linear displacement is simply the arc length. That's the amount of distance that will cover from point A to point B. Okay, and if you divide that by time, we'll find the linear speed. Okay, in this case it's tangential because you remember when I said that the velocity vector or the speed is always tangent to every point on that circumference of the circular path. All right, now this part, that's what they want us to calculate. All right, so we'll say V equals S over T. In this case, S is given. We are given this scenario where we cover an arc length of 6 centimeters in 1.5 seconds. So that's an amount of displacement that we incur in a certain period of time. So we'll say 6 centimeters divided by 1.5 seconds. Okay, 6 centimeters divided by 1.5 seconds. If we divide those two, 6 divided by 1.5, what we get is 4. Okay, 4 centimeters per second. All right, so you can convert that to meters and also see what you will get after that. Okay, now the second part that they want us to calculate, part B, is angular velocity. Angular velocity. Okay, so to calculate angular velocity, we can use a couple of ways. Okay, we can use a couple of ways. Number one, we can use, remember, when we are calculating angular velocity, we developed a relationship with it, with the linear velocity. If you remember, we said that linear velocity V equals angular velocity times r, if you remember this very well. And in the previous one, in part A, we ended up finding the linear velocity as 4 centimeters per second. So how do we find the angular velocity? That means angular velocity will be V over r. So we'll use that formula. Angular velocity is equal to V over r. So what is the V? Is 4 centimeters per second. We could have converted this, but the reason why we're not doing that is because the radius is also given in centimeters, so it will not really matter that much. Okay, so we'll write the radius in 10 centimeters. These centimeters end up cancelling. So what we end up getting is 4 divided by 10. That gives us 0.4 rads per second. Okay, every time you're calculating angular velocity, remember the units are rads per second. Okay, rads per second. Now let's calculate the last part. Now we know that if we're going to find the periodic time, we can use a method. Remember, there's a relationship between angular velocity and time period. Okay, so if we know the angular velocity, we can calculate the time period. If we make that the subject of the formula, it will be 2 pi over omega. That will be the formula that we can employ. So time period will be equal to 2 pi over omega, and 2 pi divided by omega, which we found as 0.4 rads per second. That means our time period will end up being 2 times pi, gives us that, divide by 0.4, that gives us 15.708 seconds as our answer. Okay, as our answer. All right, so that should be our time period. Okay, That is so simple, isn't it? I think it's not that complicated. It's just remembering the relationships between these things. Remember that that linear speed can sometimes be labeled as tangential speed or velocity. Okay, so all this terminology is just referring to the same thing. Now let's do the final example. Okay, let's do the final example. The final example says the wheel of a car of radius 20 centimeters is rotating at a frequency of 20 hertz. Calculate the linear speed of the car. Okay, calculate the linear speed of the car. We're given the radius equals 20 centimeters and we're given the frequency as 20 hertz. Okay, so they want us to find the linear speed of the car. Okay, linear speed of the car. So what relationships can we look at? Remember that V equals omega times R, which means that V is equal to 2 pi R over time period, or V equals 2 pi R F. Okay, so what do we have here? We have 2 pi and R. R is given. The frequency is also given. So we can end up calculating the linear speed. Now, what you have to understand is, in this case, however, we'll have to make sure that our radius is actually in meters. Okay, it's in meters. So how does that convert? It will be 200 times 1 over 100, because centi is 1 over 100. So that gives us, this cancels that 5. That's 1 divided by 5 gives us 0.2 meters as the radius. Okay, so we know the radius, we know the frequency, we can calculate the linear speed. So we'll say linear speed, which is V, equals 2 pi R F. So 2 times pi times the radius 0.2 meters multiplied by 20 hertz. Okay, that gives us times 2 times pi times 20. That gives us 25.133 meters per second. Remember that hertz is per second, and these meters, they become meters per second, and that is our linear speed. Okay, so this is very, very easy, and it's just knowing what you're given, knowing how you can manipulate it. Remember, the reason why we didn't convert the radius in the previous problem was because the units could have cancelled out. It means if we converted one thing and converted the other, it would just be constant, because we'll be converting by the same factor. Both of the variables will be converting with the same factor, and so it will not change a thing. But in this case, we have to make sure we stay in our recommended units. Remember that V, the units are meters per second. Okay, if in doubt, always use meters per second. Okay, that's how we're going to wrap up this video. Thank you so much for watching. Catch the next one, because we'll be discussing the centripetal force and the centripetal acceleration. Thanks for watching. Subscribe, and don't forget to like the video. Thanks.